Hi, welcome to Celltomic, and today we'll be learning how to form ionic equations. So in our previous video, we learned how to balance chemical equations, and in this video, we'll learn how to form ionic equations. So if you haven't catch how to balance chemical equations, I highly recommend you to go and catch that video first, either in the top right hand corner or in the link below. So we're going to learn how to form ionic equations. So ionic equations are actually chemical equations where the ionic compounds are represented as dissociated ions. So this is shown with the AQ state symbol. So this AQ state symbol actually stands for aqueous. And this represents that the compound has actually already been dissolved. So it's been dissolved in a solution. So let's look at our equation. So in this equation, we have actually calcium chloride and silver nitrate, and they react to form calcium nitrate and silver chloride. So in this ionic equation, there are a few things that we need to take note of. We need to look at the state symbol. So we see that calcium chloride has a state symbol of AQ, so that means it has been dissolved. Silver nitrate is also AQ. Calcium nitrate is AQ. And the only one that's solid is our silver chloride. The very first step is to represent all compounds that are in the aqueous state. We have to change them to the dissociated ions. So how do we do this? So we know that calcium chloride is made up of calcium and chloride. So this can be broken down into Ca2 plus and Cl minus, and always remember to put a 2 here because that's the ratio between the calcium ion and the chloride ion. Well, we're going to do this to all the other compounds that are in aqueous state. So for silver nitrate, we can break this down into Ag plus and NO3 minus. For calcium nitrate, we can break this down into Ca2 plus and NO3 minus. And remember to place the 2 in front as well because of the 2 here. Lastly, for silver chloride, since it's in the solid state, we do not need to break it down into its dissociated ions. So once we have written it down in its dissociated ions, we can rewrite the entire equation. So this equation can be rewritten as Ca2 plus and then state symbol AQ plus 2Cl minus AQ plus 2Ag plus. This 2 comes from the 2 in front of the whole silver nitrate compound. So this means that we also have to place a 2 in front of NO3 minus. And this gives us Ca2 plus equals plus 2 NO3 minus plus 2 AgCl solid. So we can see that this is the only one that didn't change into its dissociated ions. Okay, so the next step is to cancel out like terms. So you can see that I've already rewritten the equation in front, and now we're going to cancel out like terms. So how do we cancel out like terms? To cancel out like terms, we have to look at both our reactants and our products. So remember that reactants are everything on the left hand side of our arrow, and our products are anything on the right hand side of our arrow. So in this case, anything on the left hand side is everything on the top here, and everything that's on our right hand side is everything that is at the bottom here. So now we're going to cancel out like terms. Like terms meaning if we see something on the left hand side and we see something on the right hand side and they're exactly the same, we cross it out. So let's go term by term. So Ca2 plus on our left hand side, and then there's another Ca2 plus on our right hand side, so we can cancel it out. Cancel, cancel. Now let's move on to 2Cl minus. Since there are no 2Cl minus on our right hand side, we will move on to the next one. Next, we'll move on to 2Ag plus, and similarly, there is none on the right hand side, so we move on to 2NO3 minus. We can see that there is one 2NO3 minus on the left hand side, and there's another one on the right hand side, so we cancel it out. Okay, step 3 is to rewrite the equation, and then this will give us our net ionic equation. So if we rewrite our equation, we only rewrite those that have not been cancelled out. So this means we are left with 2Cl minus Aq plus 2Ag plus Aq to give us 2AgCl solid. And as you can see, this net ionic equation is actually balanced. We can see that they are balanced because we can see that there are 2Cl minus here, there are 2Ag plus here, and this gives us 2Ag and 2Cl. So this means that this ionic equation is actually balanced. Okay, now let's move on to practice. Okay, for this practice, I'm going to give you some time to try it out, and then we're going to look through the solutions together. Okay, now let's look at this question. So first things first, we need to look for those with the equal state symbol. So there is one equal state symbol and there's another equal state symbol. The rest are not in its equal state. We have a liquid state here and we have two gaseous states here. So we are only going to focus on the compounds that are in the equal state. So this NaCl and NaOH. First step is to write it in its form of its dissociated ions. So NaCl, we're going to change it to Na plus Aq plus Cl minus Aq. And we're going to keep H2O because it's in the liquid state, H2O. And this gives us NaOH equals, so we have to break it down to Na plus Aq plus OH minus Aq. And then the rest we can just write it down because they are all in its gaseous state. So step 1 is already done. We have written it out. We have written out everything into its dissociated form. This form, this equation that you see now on screen is actually the complete ionic equation. Now we want to write it down in our net ionic equation. So to do that, we need to cancel out like terms. So let's look at our terms. So on the left hand side, we have Na plus. In our right hand side, we also have another Na plus. So we can cancel those out. Cancel, cancel. Cl minus on the left hand side, and there are no Cl minus on the right hand side. So we stop there. Do remember, we only cancel out our dissociated ions. We don't have to focus on compounds that are in a solid state, liquid state, or gaseous state. We only need to concentrate on the dissociated ions. So since there are no other dissociated ions, we can rewrite the equation. So this means that Cl minus Aq plus H2O liquid gives us OH minus Aq plus H2 gas plus Cl2 gas. So that's the answer to this question. Okay, do note that this question has not been balanced yet. The equation that we see at the top here has not been balanced. So I want you guys to go and try this out yourself, to first balance the equation and then find the net ionic equation. You can post your answers in the comment section and we can see whether you guys get it right or wrong. So that's all we have for today. I hope that you have learned how to balance chemical equations and you have learned how to write ionic equations. In the next videos, we'll be tying in our mole calculation and our chemical equations together in order for us to solve some mathematical chemistry questions. So if you do not want to miss out those videos, I highly recommend you to subscribe to our channel. So thank you for supporting us, and you can also follow us on the Instagram page. And remember to always stay curious.